Hello friend, welcome back. In this session we will learn about algorithm efficiency. So as we have already seen in the last session, we can calculate the algorithm time and space complexity. So in this session we will see algorithm efficiency, or we can say that complexity also. If if a function is linear, linear means there is no loop, without any loop or recursion. So in this case the efficiency of the algorithm or running time of the algorithm, you can say that efficiency or you can say the complexity, whatever you want to call. So if a function is linear, linear means without any loop or recursion. Recursion is also will calling itself again. It is like an loop only. So without any loop or recursion, if a function is linear without any loop or recursion, the efficiency of the algorithms or running time of the algorithm can be given as the number of instructions. Simple. If you see, if I will write this statement, this statement, it means how many statements are there. Forget about this forget about this one. Before, whatever is written before to this comment, algorithm code, here you can give multi-line statement. Okay, sorry. Okay, so so you just consider these are the only statements. So it means the efficiency of what? Efficiency of this algorithm will be what? 5. It will print from 1 to 5 without any loop. This is your program. Don't consider these lines, because this is just to calculate how much time your algorithm is taking and how much time how much memory your program is taking to execute. It is just to calculate that one. That's it. These lines, and it is printing the message. Okay, so here this 5 is the now algorithm efficiency, because only the 5 statements are there. So here what it is saying, if a function is a linear without any loop or recursion, the efficiency of algorithms or the running time of algorithm can be given as the number of instruction it contain. However, if an algorithm contain loops, then the efficiency of algorithm may depend on the number of loops of a running time. Suppose, let us consider the different case in the loops determine the efficiency of algorithm. Suppose if it is a linear loop, suppose if I run this program, you will see the output. It will print from 1 to 5, and it is taking time 9. Just it is taking this much time to execute, and it is taking this much memory, 1 8 4 5 8 5 6, this much memory it is taking to execute, and this is your running time. If I again run this one, see, it depends on your CPU scheduling time or whatever. Okay, so this is taking this much time and this much memory. If you see, every time memory will be almost same. It will be almost same. Yeah, it will not vary. So this is our linear. This is our linear instructions. There is no loop at all. But the same thing you can do in this way. I less than equals to 5, or you can give it 5 and less than only. Start from 0. It is up to your choice. And I plus plus, and just print here I. in this case also output will be same. Currently the output is 1 to 5. Now it will print from again it will print from 1 to 5 only. You can take less than equal to 5, that is also fine. And if you run this one, again it will take the same amount of memory and same time. It is sometimes 3, sometimes 16, it depends, 9, same time, almost same time, because these are the linear. So now what is linear loop? This is our linear loop. Whatever the time we will run, this is our linear loop. I is equal to 1, I less than equal to 5, and I plus plus. This is our linear loop. So to calculate the efficiency of an algorithm that has a single loop, we need to first determine the number of times of the statements in the loop will be executed. So in this much, whatever the statements are there, that statement, how many time will be executed? This statement will executed 100 times here, because this loop is starting from I to 1, I is equal to 0. If I less than 100, please increment by 1 and execute this block. So first it will execute this block and then it will do the increment operation. So how much time this statement will be executed? 100 times this statement will be executed. So here 100 is the loop factor. Here 100 is our loop factor, because this loop will run 100 times. So definitely the statement will be executed 100 times. So how much statement will be there? 100 statement will be there definitely. If you write here 5 SOP statement outside this for loop, that is also same, and if you write this SOP statement inside loop, that is also same, because that definitely that will be executed 5 times only. This statement will be executed 5 times. And if you write this statement here like that, this is also 5 times it will be executing. You don't consider this is a loop, you can write here 1 2 3 4 5 like that, but that is also 5 times only. Okay, so if you see, if here you can see if the efficiency of running algorithm, if a function is a linear without any loop or recursion, if the efficiency of algorithm of running time, that algorithm can given as a number of instruction that contain. But if it has a linear loop, in this case statement also will be executed n number of time, or you can say statement will be executed. What is the loop factor? Here loop factor is 100. So here 100 is the loop factor. We have already said that the efficiency is directly proportional to the number of iteration. So it means function n. So what will be the complexity of this program here? The complexity or efficiency of this program will be function n. What is n? N is the number of iteration. So n is equal to 100. So is equal to 100. So the efficiency of this one will be 100. Okay. Hence the general formula in this case of a linear loops may be given as Fn. So this is the complexity of this algorithm. Fn is equal to n. N is the number of loops, how much time this will be executed. 100 times this statement will be executed. Okay. Next one is, however, calculating efficiency is not as simple as is shown in the above example. Consider the loop given. Now you can see this loop. Now if you see this loop, if you see, just copy here, paste it here, and okay, you can give here int. Now how much time this I will be printed here? You can run this one and you will see. See, 1 2 4 6 8 10 12 14. So it is how much time this statement is executing. How much time this statement is executing? Definitely it is executing for 50 times only. Total is 100. total is 100, but 100 is not printing here. You can see 99 and 98, 98 after 99, 90, 100 not printing. So one statement after one it is printing only, starting from 0. 1 is missing, 2, 3 is missing, 4, 5 is missing, 6. So one after one it is printing because of this one. So in this case, what will be the efficiency of this algorithm? Here the number of iteration is half the number of the loop factor. What is the loop factor? Loop factor is 100, but increment and decrement is happening in 2 plus 2. It means, so here the efficiency can be given as fn n divided by 2. Whatever the iteration you will have, n is the number of iteration. If number of iteration is 100, then divided by 2, 50. If number of the iteration is 50, divided by 2, 25. Like that, the efficiency of this algorithm will be defined here. Okay. Next one is a logarithmic loops. Logarithmic loop means we have seen that the linear loops above 2 are linear. This is a linear, directly proportional to the number of iteration. N, how many, that much time it will be executed. If it is increment by multiplied by 2, or if you see if you do plus 3, then how much time it will be executed? You just run and you just see. 1, 2, 3, 2 and 1 and 2 missing, 3, 4, 5 missing, means divide by 3, 100 divided by 3, simple, 100 divided by 3 only, because 3 times it is incrementing, 3 it is adding whatever the value is there, I, it is adding 3. Okay. Or if you want to calculate, you can write here one count variable is equals to 1. Every time whenever it will be executed, increment this count to plus. Count to plus only. And after this one, what you do? You print the count. You will understand how many times this loop is executed. You can very easily you can understand 35. Okay. So this is a 3 time of a, you can say that is a 3. Okay, approximately it is 3 because it will not take your friction part. Okay, fine. Fine. So this is the linear loop, or linear loop that may vary how you are doing increment or how you are doing the decrement. Okay, fine. Next one is, because this is 2 divided by 2, that's why it is divided by 2, or it may be divided by 3, because if you are incrementing by 3, whatever value is I there, increment by 3, that's it. Okay, next one is a logarithmic loop. What is logarithmic loop? If you are doing any multiplication or division, suppose we have seen that the linear loop updated statement either add or subtraction. In the linear loop we have seen that in linear loop the loop updated loop updation statement either adds or subtraction the loop controlling variable. However, in arithmetical loop the loop controlling variable is either multiplied or divided during each iteration of the loop. For example, look at the loops given below. So if you give this loop, then what will happen and how much time this will be executed. Just run and see. 11 times only 11 times, because I we are multiplying by 2. We are multiplying by 2, or you can say divide by 2. Or I divide by 2. It's not executing even in a single time. It's not executing, but in multiplication case, it is executing for 11 times. Yes, 11 times it is executing. So how we will give the complexity or efficiency of the algorithm in this case? So consider the first loop in which loop controlling variable is multiplied by 2. The loop will be executed only 10 times and not 100 times, because this is giving you 1000. Sorry, you are giving here 1000 times you are giving. So so the loop will be executed only 10 times and not 1000 times, because in each iteration the value of I doubles. Now consider the second loop in which the loop controlling variable is divided by 2. In this case also the loop will be executed 10 times, but this loop is given in some different case. Now sorry, I also forgetting this one. This was given in this way. This time also this will be executed 10 times only. You can give this as a 0. If 1 is happening, it will execute 1. Yeah, 10 time only. Or if you give this one also, this will executed only 10 times. Only 10 times, because it's either it is doing a multiplication or either it is doing int I. Okay, then also it will be executing for 10 times. Okay. Okay, fine. And if you take the example of this one, in this case it is making double only, so definitely it will execute for 50 times 50. And if you are making it is a plus 3, then it will be executed for 34. Okay, fine. So that is the logrammatic loop. In logrammatic loop, so in logrammatic loop, consider the first loop which the looping control variable is multiplied by 2. The loop will execute only 10 times and will not execute 1000 times, because each iteration the value of I doubles. Now consider the second loop in which the loop controlling variable is divided by 2. In this case also the loop will be executed 10 times only. Thus the number of iteration is a function the number of iteration is a function of the number by which the loop controlling variable is divided or multiplied. In the example discussed is it is 2, that is when n is equal to 1000. The number of iteration can be given by 1000, which is approximately equal to 10. So therefore, putting this analysis in general term, we can conclude that the efficiency of loop in which iteration is divided or multiplied the loop controlling variable can be given as function n. Now what is n? N is a number of iteration. So log n will be what? Log n will be here 100, then it will be 10 only. Okay, so the complexity or the efficiency can be defined as Fn is equal to a log n. Okay, next one is nested loop, loop inside loop. Nested loop means loop inside loop. Loops that contain loops are known as nested loop. In order to analyze nested loop, we need to determine the number of iteration each loop completes. The total is then obtained as the product of the number of iteration in the inner loop and the number of iteration in the outer loop. So in this case, we analyze the efficiency of an algorithm based on whether it is a linear, logarithmical, quadratic or dependent quadratic nested loop. So first one is linear logarithmic loop. So if you see this loop, consider the following code in which the loop controlling variable of the inner loop is multiplied each time iteration, after each iteration, and the number of iteration in the inner loop is log 10. Definitely this is what? This is, we are doing multiplications here. So definitely for this inner loop, this is our inner loop, j is equal to 1. Here we are initializing j is equal to 1 and j less than 10 and j into 2. So definitely how much time it will run? It will run 10 times, or you can give here 0. So it will run 10 times. Currently this is executing 9 times only. So log 9 you can give like that, or log 10. So it should be executed 10 times. Just make it a 0 here. So it will executing 10 times. So log 10, because of this is a logarithmic. This increment or decrement is happening in multiplication or division, you can see here. So this is a log n. Definitely this is, for this one the complexity or the efficiency is log 10. And outer side how much? I is equal to 0, I less than 10 and I plus plus. So definitely n. So n log n. That's it. That is the efficiency of this loop here. So the number of iteration in the inner loop is log 10. The inner loop is controlled by an outer loop which iteration is 10. So that can be defined by n. So therefore, according to the formula, the number of iteration for this code can be given as 10 log 10. Definitely n you can represent by n, you can replace with the 10, because here is the number of iteration is what? 10. So 10 log 10. Log 10 is what? Log 10 is because this increment decrement is happening by multiplication or division. That's why you can give this, the complexity for this one, log n, and n is the upper 10 times. So n log n, 10 log 10. Okay, in the more general term, the efficiency of such loop can be given as fn, function that has an n number of loops. So a functionality for this one, n log n. Okay, fine. Next one is quadratic loop. So this is what? This was a linear logarithmic loop. Next one is quadratic loop. So in quadratic loop, the number of iteration in inner loop is equal to the number of iteration in the outer loop, if it is equal. Definitely if it is equal, then outer loop, consider the following code in which the outer loop execute 10 times. Outer loop is executing 10 times. You can see here I is equal to 0, I less than 10 and I plus plus. So what will be the complexity for this one? N will be the complexity for this one. And what will be the complexity for this one? Multiply this also. j is equal to 0, j less than 10, this is also again will be 10, and j plus plus, so this also will be 10. So n, you can say like that, 10 into 10, 10 this time, this is a 10 time complexity. For this loop the complexity is 10 time, and this is also having a 10 time, so you can multiply these two, 10 into 10, 10 into 10, and in the general formula you can write is n square, you can write as n square, and 10 into 10 is nothing but 10 square only, so you can give n square. If it is a quadratic loop, quadratic loop means the inner loop and outer loop has the same number of iteration. If it is a different number of iteration, then you can directly multiply n into whatever the n into x, you can give like that. But if it is the same number of iteration, then that is a quadratic loop, and for quadratic loop the complexity will be n square. Okay, next one is dependent quadratic loop. Dependent quadratic loop. Now in this case what will happen, this loop is depending on this loop. Suppose in dependent quadratic loop the number of iteration in the inner loop is dependent on the outer loop. Consider the below code. So here I is equal to 0, I less than 10, and I plus plus. So what will be the complexity for this one? N, because 10 time it will be running, so 10, you can say that is a 10. Currently the complexity is a 10. Okay, 10 into this one, what will be, how it will be? So first time, how much time this will be running? J is equal to 0, j less than equal to I. Currently I is 0, it will run one time, it will run one time. Next time it will be 2, so it will running 2 time. So this statement, now this statement is executing, first it is executing one time, then it is executing 2 times, then it is executing 3 times, then it is executing 4 times. That's it. And in this case we can directly add those. You can directly add, because first time this statement is executing one time, because this is a dependent quadratic loop. In that case we are adding, but before it was a quadratic loop. In quadratic loop it is a direct proportional, we can directly do the multiplication, but in case of dependent quadratic loop we have to make here multiplication. So first time, if you see, this statement will be executed one time. If I copy this one, and if you see here the result, int and int, that's it. And here what will be the statement? Just count making plus plus, that's it. So now you see how much time, what will be the value for this count? 55. How? Suppose take the example first of this one, what will be the complexity? 10. What will be the complexity for this one? You can't predict. It depends on this I, only. What will be the value of I? First time 0, it will execute only one time. Next time it will execute for 2 times. 3, 4, 5, 6, 7, 8, 9, 10. Like that only this will execute, and it will go up to first time 1, 2, 3, 4, 5, up to 10 only. It will go up to 10 only, because max is the 10 only. This condition is dependent on this one, so definitely first time it is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. So directly we can make the the sum of all the 10. So what is the general formula for this one? Whatever value will be there, n. So this is simple. This is the formula, that what will be the sum of first n natural number, n into n plus 1 divided by 2. That only, n into n plus 1 divided by 2 only. If I say you see, okay, so if I say what will be the sum of first 10 natural number, first 10, suppose, so how will you do, suppose I is equal to, start from 1, I less than equal to 10 and I plus plus, and here is the count, inside count I am counting the sum. So count plus is equal, plus is equals to I. Now what will be the the value of count? 55, because the sum of first natural number will be defined as n into n plus 1 divided by 2. So if you see, this statement is taking some time to execute, like 2 time it is saying here, 2 it is taking. But if I do another thing, I will do n. What is n here? 10, our number. Statement is 10 only, our iteration, or that was nothing but the number. So how I can do that one? How I can do count is equals to n into n plus 1 divided by 2 . Okay, what is this one? Okay, fine. So you can typecast to int and undefined. Okay, sorry, that is okay. Into, it should be into n plus 1 divided by 2. Same only, result will be same, 55. So this is the general formula. If it is a dependent quadratic loop, you can directly do the n into n plus 1 divided by 2. That is the what? This is the complexity or efficiency of this algorithm. So if we calculate the average of the loop, 55 divided by 10, 55, we will observe that it is equal to the number of iteration in the outer loop, 10 plus 1 divided by 2. In general term, the inner loop iteration n plus 1 divided by 2 only, inner. This will be the inner complexity. Whatever n will be there, plus 1 divided by 2. Therefore, the efficiency can be efficiency of such a code can be given as n into n plus 1 divided by 2. Okay, so this is for this session only. In the next session we will see the big O notation. So some notations are there in data structure and algorithm that will define what will be the maximum complexity, what can be the minimum complexity for this one. So we will learn all those in our upcoming session. So in the next session we will see big O notation. So I hope you like this session. Please subscribe my channel and we will see you in the next session. Till that, bye bye and thanks for watching.